So we're going to talk about dihybrid crosses tonight. You're going to need your power notes, so if you do not have them, go ahead and pause the video and go get your power notes and then come back. So we're going to refer to number 13 on your power notes. A dihybrid cross shows the results of two genes at the same time. It is done with a 16-box Punnett grid, which is the same thing as a Punnett square, or with a fraction method. The fraction method is a little bit more complicated, and we're not going to get into that in this class. For example, cross a plant with heterozygous round seeds and heterozygous yellow seeds with a similar plant. Okay, so they're wanting you to cross two plants that have the same genotype and figure out what their offspring's genotypes would be. Okay, so heterozygous round seeds and heterozygous yellow seeds. So the R's represent the roundness of the seeds, and then the Y's represent the color of the seeds. Big Y is yellow, okay, so that's the dominant, and then big R is round, so that's dominant. So each of these are heterozygous for each of those traits, which are passed on together. Okay, so I've put their genotypes up here. This is mom, this is dad. So I put mom down this side. So what I did was I took all the possible combinations of these genes from her, or these alleles from her genotype. I said big R could potentially go with big Y, and I put that right there. Big R could potentially go with little y, and I put that there. Big R, I already did that one, sorry. Little r could potentially go with big Y, put that one right there. Little r could potentially go with little y, so I put that there. Okay? So it's almost like the foiling method. So then I did the same thing for this one because it's the exact same, so I wrote them out on this side too. And then I crossed them just like I would in one of our regular Punnett squares. Okay, so I said big R, big R, big Y, big Y, big R, big R, big Y, little y. Okay, so I crossed all of these. I want you to try to do it on your own without looking at this one, okay, once I get done with this video. Alright, so now we have all the possible offspring genotypes, okay? And what we can do is we can count up the amount of each one, okay? So we can count up how many are big R, big R, big Y, big Y, okay? And then we can count up how many are big R, and big Y, little y, which is what this one was. I messed up right there, okay? And you figure out all the possible results, and then you find out how many of each there are. So we're going to solve some of these in class tomorrow. It's okay if this is a little fuzzy and you're not quite sure about it, but at least you kind of know the basics, alright? So go ahead and look at this, try to solve this on your own without looking at this table that I've already finished out, and see if you get the same answers that I did. Alright, make sure you bring your notes tomorrow for credit for homework.